Hey guys, welcome back to another episode in the Deep Learning with Tensorflow series. This is going to be a quick episode where I show you guys how to get the model summary and also show you that the input layer is optional. Alright, so this is the notebook that we used last time when we did the IMDb binary classification. And what I'll do is just modify this real quick and I'll show you that if we comment out the input layer, which we use to define the shape of the input that the neural network should expect, it'll still work. It's still going to train it the exact same way, nothing will change. One thing that we can actually do though is get the summary of our model so we can see the full architecture of it. So let's move on. Let's move the fit part to a different code block so we don't have to retrain it every single time. And then before we fit our model, let's do model.summary. So this will return a summary of your model and we can print it out. So let's run it now. Here we go. So we get this little table here that shows the layout of the model. So we can see that there's a layer column that describes the layers of the model. So it starts with our first hidden layer. It does not list our input layer. So that's why you see the first one listed as just, dense 27. That's just the name given to it randomly. And you can see it's a dense layer. It also tells you the output shape of that layer. So we can see that has 64 neurons. So the output shape will be 64 in size. So it gives you 64 numbers per sample. And then in the last column, we see the number of parameters in that specific layer, which is our model weights and biases. So that's for our first hidden layer. And then we have our second hidden layer, which is also a dense layer. They're all dense layers, but this one has an output of 32 because that's what we specified. And this one has a smaller parameter size because the output is much smaller. So something interesting is that you'll see the number of neurons that you have in your layers will kind of exponentially factor into how many number of parameters you have, because all we're doing is having it, but you can see that the difference in number of parameters is extremely large. And then we have our last layer, which is our output layer that only has an output of 1 because we're just trying to output a probability, and this one only has 33 parameters. And then at the very end here, we get the total parameters for the entire model, 2.45 megabytes. These are all trainable parameters, so as we train the model, these are going to be adjusted up or down. So again, the number of parameters is our model weights and also our biases. And the calculation for every single layer is going to be this. So it's the number of input features, or the size of the input that you're feeding into that layer per sample, times the number of units or neurons, plus the number of units or neurons for the bias. So for example, if we have an input size of 3, 1, 2, 3, and then the number of units is 4, 1, 2, 3, 4 neurons, we know that every single input is tied to every single neuron. It has a connection to every single neuron. That's why it's called a dense layer. So to get the number of parameters, it's simply the number of inputs times the number of neurons, or the units. So that would be 3 times 4, which is 12. But then we also know that every single neuron has a bias term associated with it. So we would add on another 4 units to account for the bias term. So that is why it is input features times units plus units for the bias, okay? So for this first layer that we have here, the number of parameters is 640,000 roughly. That is calculated because we have a shape of 10,000. We know that every single vector we feed into our network is going to be 10,000 features, or 10,000 elements in each vector. And so that would be 10,000 times 64, which is 640,000, plus another 64 for the biases for each neuron, which is 640,064. So hopefully that calculation makes sense. Likewise, for the last one here, we have a input from the previous layer, which is 32 in size. So it'd be 32 times 1 and then plus 1. So that's why you get 33. So as you can imagine, the model summary is pretty useful for us so we can see information about the model. But one thing is that if you have the input commented out because the input is not required, the summary no longer gives you any useful information, because since you haven't strictly defined what the size of the input will be, it doesn't know what number of parameters you have and all that stuff. It can't really make that calculation until you actually start using the model, okay? So with that said, the input layer is optional for the sequential Keras model. You can have it or you cannot have it, just depends on what you want to do. It's easier to not have it, but if you want a summary that is useful to provide you more information, then you should just have it. And I think just generally speaking, it's kind of cool to have the input anyway, so you really just know ahead of time this is the size of the data they're going to be feeding into this model. I think it just makes sense that way. So with that said, that's it for this episode, everybody. Hopefully you found this interesting. That's how you can use the model.summary function to print out a summary of your model. And then also you saw that the input layer is optional, okay? Thanks for watching, everybody.